How's it going, guys? It is now a quarter after 10. I just got home from our last class, and I'm just going to finish up the review with you guys. I might go a little fast, so if you need to rewind, um, definitely do that. I'm pretty tired. I just want to get this done. So, question number 20 says, write a cubic expression with one variable whose leading coefficient is 4 and whose roots are 0, -2, and 7. This is going to be real easy if you remember the factored form of a polynomial p of x is our leading coefficient a times x minus root 1 times x minus root 2 times x minus root 3, and this keeps going for as many roots as you have. They tell us it's a cubic expression, so that's our first clue. Cubic means that our largest exponent is going to be 3. So all we need is 3 linear factors, 1, 2, and 3, and we're done. So they tell us the leading coefficient is 4. So that means that A is 4. That's our leading coefficient. The roots are 0, -2, and 7. So all we have to do is write this as x minus 0, x minus -2, and x minus 7. Okay, neaten this up a bit, you get 4 times x plus 2 times x minus 7, and we're done. So please remember, factored form of a polynomial is p of x equals a times x minus root 1, and these are all your linear factors. Linear factors of p of x. Okay. Question number 2, 1D1. Write a polynomial with one variable x, which when evaluated at each of x equals 0, x equals -3, and x equals 1 gives us 0. This is the same question as above, so they're just wording it a little bit differently. So write down a polynomial when evaluated at x equals 2 gives us 0. So what they're saying is when x equals 2, y equals 0. When x equals -3, y equals 0. When x equals 1, y equals 0. Okay, I'm going to go ahead and just sketch this out so you can kind of understand what they're saying. They're saying that when x is 2, y is 0. When x is -3, y is 0. And when x is 1, y is 0. So you have a polynomial that passes through those 3 points. These are our roots. Okay, they didn't say it explicitly, but that's what it means. Okay, so this is the same question as before. Polynomial p of x equals a times x minus root 1, which is 2, x minus root 2, which is -3, so I'm going to write that as plus 3, and x minus root 3, which is 1. Okay, we don't have a defined. They don't tell us what a is, so the easiest thing would be to make a 1. Please remember, a cannot equal 0 because then that would not be a polynomial. That would be a constant, 0. So we can say our final answer, p of x, is just 1 times x minus 2, x plus 3, and x minus 1. Okay. Number 22. Use a binomial theorem to find the coefficient of x to the third in the expression 2x minus 1 equals, 2x minus 1 to the fifth power. So like we briefly explained before, we're going to use Pascal's triangle for this. And let's quickly build that. That's 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Adding up the terms above to get the terms below. Sorry, adding up the numbers above to get the number below. We have 1, 5, 10, 10, 5, and 1. So this is the row that we're going to use to get our coefficients. So let's write our coefficients out. Let's space them out. 1, 5, 10, 10, 5, and 1. In this case, 2x, that's our a value, and -1, so I'm going to write this as plus -1. So -1 is our b value. So we're going to take our a value, and since we're raising this to the 5th power, we're going to take our a value and write that to the 5th power to start this expansion. So that's going to be 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x squared, 2x, and 2x to the 0 is just 1, so I'm not even going to write it. If it makes more sense, I'll leave it there, but it's going to go away. It's just going to become 1 when we cancel that out. Okay, now remember our b value is -1, so we're going to start on the right side, and we're going to go -1. Because our exponent is 5, we're going to go -1 to the 5th here. In between all of these is plus, so we have -1 to the 4th, -1 to the 3rd, -1 squared, -1 to the 1, and -1 to the 0. Again, anything to the 0 power is 1, so that's going to cancel out. Let me zoom in a bit so you guys can see what's going on here. Okay, so let's simplify this. Let's neaten this up a bit. 2x to the 5th, well, that's 2 to the 5th, which is 32, and x to the 5th. So our first term is 32x to the 5th because I squared 2x. Sorry, I raised 2x to the 5th power. And next we've got 2x to the 4th, which 2 times 2 is 4 times 2 is 8 times 2 is 16. So this gives us 16x to the 4th. Let's not forget that we're also multiplying this by 5 and by -1. So 5 times 16 is 80. And we have the -1 there, so this is going to be -80x to the 4th. All right, moving right along. We've got 2x cubed, and 2x cubed, 2x times 2x times 2x is 8x cubed, and we're multiplying this by 10, and -1 squared is 1. So this is just going to be 80x cubed. And because they're asking us for the coefficient, find the coefficient of x to the 3rd power, we're done. We can stop there. Our answer is 80. But I'm going to show you what the rest of this expansion looks like. So next we've got 4x squared. That's what happens when we square 2x times 10, and -1 to the 3rd power, that's actually -1. So this is going to give us minus 40x squared. Next, we've got 2x to the 1, which is just 2x times 5 times -1 to the 4th. -1 to the 4th is actually just 1, right? -1 times -1 is +1, and +1 squared is still +1. So this is going to be positive 10x. And then lastly, we've got -1 to the 5th power, which is just -1. So this is our full expansion of 2x minus 1 to the 5th power. This whole thing, 2x minus 1 to the 5th power, that's this. Okay, I said that I would give you the explicit equation for the binomial expansion theorem, and that is as follows. So switch colors because this is a theorem. A plus b to the n equals n choose 0, a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the 1, plus n choose 2, a to the n minus 2, b squared. And then this pattern continues up until we get to our last terms. N choose n minus 1, a to the 1, b to the n minus 1. Lastly, n choose n, which is going to be multiplied by a to the 0 power, b to the n power. Okay, so this syntax here, where we have n over some number, in your calculator, you can find this. Let's say, for example, if we wanted to do 5 choose 3 in our calculator, say we wanted to find the 3rd term, here, right? That's going to be, in your calculator, you're going to look for NCR, and the arguments are going to be 5 and 3. Okay, so we could just go to Pascal's triangle and just look at the 1, 2, 3. So this value here, this correlates to 5 choose 0. This correlates to 5 choose 1. This 10 over here, this is 5 choose 2. And this 10 here, let's do this in red so it sticks out. This one is 5 choose 3. Okay, so if you ever get to combinatorics, 5 choose 4 is 5, and 5 choose 5 is 1. What this is saying is how many ways when we choose from 5 objects, how many ways can we choose 0 objects? Well, there's only one way we can choose nothing, and that's one way. This next part here, 5 choose 1. How many ways from 5 objects can we choose something? Like say, for example, how many ways can we choose a finger from our hand? Well, there's 5 ways: thumb, index, middle, ring, and pinky, right? Here, 5 choose 2. How many ways can we choose 2 fingers out of 5? So there's 10 ways to do that. I'm not going to list all 10 because that's not what they're asking. They're just asking for the coefficient of our third term. So we can use Pascal's triangle and just jump straight to this times a, in this case, 2x to the third power. So we got 5 choose 2, which was 10, times 2x to the third power, which is 10 times 8 times x cubed, which is where we got 80. So you can do this a little bit faster if you know what to look for in your calculator. All right, next. Number 23, assuming the variables take on positive values, simplify and write your answer as a simple fraction using only positive exponents with each variable appearing at most once. Okay, so this is a lot like the other question where we have a whole bunch of variables and exponents. I'm only going to do one of these for the sake of time. Let's start on the inside, and let's remember our exponent rules. Remember, anything raised to, say, to the 3 divided by a to the 5, this is a to the 3 minus 5. So when we're dividing, we're subtracting our exponents. Okay, so let's start off. Let's first look at the constants. 4 over 16. That is going to simplify down to 1/4. Okay, so I like to split these up along variables and constants because it's called compartmentalization. We're just solving the pieces that are easy, and then we're gonna bring it all together at the end. Notice I'm putting this inside of a parentheses, and then at the very end, I'm gonna raise this to the power of -1/2. You don't need to do it this way, but you're less likely to make mistakes if you compartmentalize. Okay, let's look at the next one. X to the third and x to the -3rd. Again, when we're dividing similar bases, we're subtracting the exponents. And furthermore, when we do that, this leaves us with over 1. So a to the 3 over a to the 5 is the same thing as a to the 3 minus 5, which is the same thing as a to the -2, which is the same thing as 1 over a squared. So here's a little shortcut. If the denominator has a larger exponent, like say here in this example, we have a to the 5, when we subtract, we're going to, instead of doing 3 minus 5 and putting it up top, we can do 5 minus 3 and put it in the bottom. Okay, but here, our numerator is definitely, the exponent is definitely larger than the exponent down here. So we're just going to do x to the 3. Where should I write this? Let's do this in blue. So this section here in blue, that's x to the 3 divided by x to the -3, which means we can write this as x to the 3 minus -3, which is x to the, we add these, so we get x to the 6th in the numerator. So I'm going to write that as x to the 6 over 1. Okay, lastly, let's do this in green. So we have our y terms doing the same thing. Y to the negative 2 divided by y to the 4 is the same thing as y to the negative 2 minus 4, which is y to the negative 6, which is 1 over y to the 6. So that means that our last part here is going to be 1 over y to the 6th. And remember, this is all to the negative 1/2 power. So let's neaten this up a bit. Let's put this all in one fraction. So that's going to give us x to the 6th over 4y to the 6th raised to the negative 1/2 power. All right. Now, because our exponent is negative here, we can go ahead and flip this entire fraction. So now we have 4y to the 6th over x to the 6th raised to the 1/2 power. Now we don't have a negative exponent, and now we can distribute this 1/2 power. Remember that a to the x, which is then raised to the y, is the same thing as a to the xy. So because raising an exponent to another exponent, we just multiply the exponents, we can say, oh, that in conjunction with the following rule, a times b to the x is equal to a to the x times b to the x. When we apply both of these exponent rules at the same time, what we're essentially saying is this 1/2 exponent up on the outside, we can distribute that to each of our exponents in the numerator and in the denominator. Okay, so what I'll do is I'll split this up for y to the 6th to the 1/2 power over x to the 6th to the 1/2 power. Just so you can see that's we're using the quotient rule. So that's what we did here. And then we can apply that distribution that I mentioned here to rewrite our numerator as 4 to the 1/2 times y to the 6 to the 1/2. Well, we can multiply that, so that's going to be 6 over 2 all over x to the 3. Sorry, I'm one step ahead. X to the 6 over 2. Okay, we're almost there. We just need to find the square root of 4, which is 2, times y. Now, 6 divided by 3 is y. Sorry, 6 divided by 2 is 3. But this leaves us with y to the 3rd, which is slightly problematic because we're starting off with y to the 6th, a positive, a function that's always positive over its domain. So if we look at y to the 3rd, it has a negative output value. So we actually need to put absolute value here. I don't think the math department at City Tech really cares about this absolute value, but in case they do, just remember that this needs an absolute value, and here's why. Uh, if we look at x to the 3rd power, if we were to graph this on our graphic calculator, we would get this cubic shape here, which has a negative region over here on the left, right? But we started, remember, we started with x to the 6th, which looks like this, and then we took the square root. Well, on the right side, the square root of a positive number gives us a positive number. On the left side, the square root of a positive number should also give us a positive number, not a negative number. Okay, so that's why we need the absolute value here. Okay, so this I would say is an acceptable answer. I would also say you can write this as 2 times the absolute value of y cubed over x cubed. But I think this is acceptable, this is acceptable, but this though it may be acceptable, is not technically correct. Okay, so if you were to graph this, you would get that incorrect. We would need the absolute values. I'm not sure how they're going to do it. They tell us in the question, assume the variables take on positive values. Okay, so because they said that, because they said assuming the variables take on positive values, we don't need to worry about the negative values, so we don't need the absolute value. So actually, we can leave it like this. This is okay. All right, I'm not going to do the other ones because that just take way too long. So that was 23. Question number 24. Write an equation of a line which is perpendicular to this line and passes through the point 2, -1. Okay, so let's recall that the slope, usually denoted with the letter M, the slope of a perpendicular line is equal to the negative reciprocal of the slope of our original line. So our first step here is to determine the slope of this equation, which we can see if we write this as y equals 2x plus 4 plus 3. If you notice, all I did was I added 3 to both sides here and here to cancel that out. If you notice, that is the point slope form of a linear equation. So right there, we know our slope is 3. So that's the slope of this line. If we want to graph or find the equation of a line perpendicular to this, we need to then take our formula here for perpendicular slope is equal to -1 over m. So our perpendicular slope is going to equal -1 over, in this case, 2. Okay, great. So now we have our new slope, and we're going to use the point slope form again. I might as well write it for you guys. Point slope form of a linear equation is y equals m parentheses x minus h plus k, where h and k are any point on the line. Any point on the line. Okay, so please don't get confused here. They're giving us two lines. They gave us the equation of one line, y minus 3 equals 2 parentheses x plus 4, and they're asking us to write an equation of a line, a new line, which is perpendicular to this original line. So step 1 was to find our perpendicular slope. Step 2 is to put this new slope into the point slope formula using 2 and -1 as our new h and k values. So that will look like this. Y equals -1/2 x minus 2 minus 1. Okay, so this line, this is our perpendicular line. Okay, they don't give us graph paper to graph this, which sucks. So I'm just going to try my best here. Graphing the first line, um, we know that the point that we're going to focus in on is if this is x plus 4, that means h for this line, the point that they gave us is going to be, h is going to be -4 and k is going to be 3. So I'm going to find the point -4, 3. 1, 2, 3. And they also give us the slope. So that means that our average rate of change is 2. Every time we go right 1 unit, we go up 2 units. So right 1 up 2, right 1 up 2. And we can also take that in the other direction. Left 1 down 2, left 1 down 2. And I'm going to connect these with a line, maybe? Yeah. So that's our first equation. That's the one that we gave us. And our perpendicular line, this one, according to this formula, passes through the point. Here, h is 2 and k is -1. So let's go ahead and graph those points on our makeshift crappy grid here. H is 2, K is 1. So the point 2, 1, let's graph that point there. And our slope is -1/2. So that means we're going to go down 1, right 2. please recall our slope is rise over run. So having a slope of a perpendicular line equal -1 over 2, what this is telling us is this is a set of directions from a point on the line, which we know is 2, -1 is a point on the line. We're going to go down 1 unit because we have a -1, and this tells us to go right 2 units. Right, so that's why I'm plotting these points here. Down 1, right 2, down 1, right 2. We could also go in the opposite direction because -1 over 2 is the same thing as 1 over -2. So we can read these directions as going up 1 and left 2. Because remember, slope by definition is rise over run. Slope by definition is the change in y values over the change in x values. So our numerator tells us go up or down, and our denominator tells us to go left or right. Please remember. Okay, so instead of going down 1, right 2, I'm going to go up 1, left 2, up 1, left 2, 1, left 2, and up 1, left 2. And I'm going to connect those dots with a line. And we can see that these two lines are perpendicular. Okay, definitely run this back. Try questions like this on a graphic calculator. Maybe make up a new equation and choose a point in space. They're all going to be solvable. All right, question number 25. A lot like 24, we need to recall the equation for a slope of a line. So recall that slope is equal to y2 minus y1 over x2 minus x1, which can also be written as, just like up here, delta y over delta x. So when we have 2 points here, it might be easier to keep your data organized. Let's call this x1, y1. Let's call this x2, y2. And then we just plug it in to find our slope. So therefore, slope is equal to y2, which is 4, minus y1, which is 3, over x2, which is 3, minus x1, which is -2. So 4 minus 3 is 1. 3 minus -2, minusing a negative is really adding. So this is 3 plus 2, which is 5. So our slope is 5. Great. So now we can plug this into the point slope form of a linear equation. I'll scroll up to remind you what that is. That's here in the blue box. And it doesn't really matter which point we use. Either one, it will give us the same equation. So I'm going to use 3 and 4 for h and k simply because the values are positive and I don't want to deal with negatives. So our line that passes through these points is going to be y equals 1/5 times x minus h, which is 3, plus 4, which is k. Okay, definitely take these points to Desmos and graph them. -2, 3, and 3, 4. 1, 2, 3. 1, 2, 3, 4. We can see from here to here, our slope is up 1, right 5, so that matches. And yeah, that's your answer. Number 26. Oh, this one is involved. So I want to make sure you guys can solve this relatively quickly. First things first, our vertex of our parabola is at -1, -9. So let's just write everything we know. Let's annotate. That means, therefore, h is -1 and k is -9. Great. Next, let's notice that if we were to look at our vertex, if we take one step to the right from our vertex, one step right, our next point is one step up. One step up. which is what it should be when a equals 1. So this right here tells me that a equals 1. Our leading coefficient is 1. Okay, so if our leading coefficient is 1 and our vertex is -1 and -9, we're pretty much done. We can define this function. It's a quadratic function, so we're going to use the vertex form of a quadratic function, which I'll remind you, a lot like point slope form, it's going to be y equals a, our leading coefficient, times x minus h squared plus k. So let's plug this in. Y equals, we know our leading coefficient is 1, so we can just not write it. X minus -1, so that's x plus 1 squared minus 9. We could go ahead and turn this into standard form. Notice I'm doing all this without even reading the questions because I know there's some questions involved, and let's just get this out of the way. So standard form, what we have to do is multiply this x plus 1 times x plus 1, and then subtract 9. So that's going to give us x squared plus 2x plus 1 minus 9, which is x squared plus 2x minus 8 in standard form. Okay, also, this is nice. They gave us the roots. They gave us root 1 and root 2. That's root 1 and that's root 2. So we can go ahead and write this in uh, factored form as well. We have enough information here to write this in all three forms. So our factored form, factored, standard, and vertex. Our factored form is going to be y equals, let's get these, y equals, remember, just like the factored polynomials that we covered in the previous question, the very first question, all we have to do is multiply our leading coefficient, which we know is 1, times x minus root 1 times x minus root 2. This question is a quadratic, so we only have two possible complex roots. Luckily for us, they're both real, and we can just write this as y equals a. I'll write the formula first. And finally, x minus our first root, so that's x minus -4, which is really x plus 4. And why is that? It looks like a 9. X plus 4. And then over here, x minus 2. Okay, let's just confirm that these functions that we've written are correct. You can see here our y-intercept is -8, which matches here. Here we have roots -4 and 2, which match these. So we have all three forms of this equation solved. So let's answer the first question. How many solutions of the form a -4 does this equation have? So what they're saying is if a is 1, y is -4. This only has one solution. Explain? Well, clearly there's only one 1, -4, but also this is a function. This is a quadratic equation. We can't have more than one solution for one y value, or for one x value. Our x value is locked into a, so that is not going to work. Now, if they mean a different leading coefficient, if the a that they're talking about is not this a, then we would have two solutions because then a could be 1 or -3. So depending on what they're asking us, this is a pretty weirdly worded question. I think this a here is not the same as this a here. If that's the case, then we've got two solutions. So one solution, if a is the a from ax squared plus bx plus c, So if this A comes from this A, then there's only one solution. This will have two solutions if A is independent, which if A is not that, so if A is independent, and those two values of A would be A equals -3 and A equals 1, because we can graph those 2 points here and here. One, sorry, the y value is -4, so it's up here a little bit. So that's a -4, and this one is also a -4. No, 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 no. No, A can only be one number. So it's a weird question. Why do they ask questions like this? Why do they ask questions like this? If A is independent, A can be these two values here between here. So the answer would be 2 if A is independent. 1 if A is the same A as our leading coefficient. So weird. How many solutions of the form root 3b does this equation have? Okay. When x is root 3, which is here, there's only one possible y value via the vertical line test. So vertical line test says we can draw a vertical line through this quadratic function. It only passes through once. So this only has one solution. And that is, well, whatever the y value is at square root 3. How many solutions of the y coordinate of -15 does the equation have? Well, the graph never reaches -15. It never reaches there. So this is going to be no solution. Explain? Well, because our graph never reaches. It never goes that low. Okay, next, find the roots of this. Well, we found that already. Great, we found those roots. Remember we said earlier, root 1 is this x-intercept, so root 1 is -4. Root 2 is 2. So we already know our roots are -4 and 2. -4 and 2. What is the value of the constant coefficient? Remember, the constant for a polynomial written in standard form is going to be our y-intercept. Explain the reason for that is because when we plug in x equals 0, the x squared term will cancel out, the bx term will cancel out because they both will become 0, and we're left with c by itself. So when x is 0, aka along the y-axis, our y value is just c, aka our y-intercept. Next. Is the coefficient a positive, negative, or 0? Explain. The coefficient is definitely positive, right? Why? Because it's concave up. Okay. Next, how many of the solutions of the system y equals ax squared plus bx plus c and y equals 3 have? Explained. Okay, so we didn't really do a lot of system of equations by graphing because you don't use the graphing calculator in the test. But to solve this, we would just graph the first equation, which they have graphed for us nicely. And the second equation, y equals 3, remember that's a horizontal line at y equals 3. It's a horizontal line. All x values don't matter. Y value is 3. So that represents as a horizontal line. So I'll draw that. So this blue line here, this would be the line y equals 3. And remember, the solution to a system of equations is where the two curves meet. So that's this point here and this point here. Therefore, this has two solutions. This has two solutions because this first curve and this second curve intersect at two places, here and here. All right, we're almost done. Find the equation for the line of symmetry. Huh, easy. Remember, the equation for the line of symmetry is x equals h, which is negative b over 2a. But luckily for us, we know h because h is the x value of the vertex. So let's put this colon. Our axis of symmetry is going to be the x value of the vertex. And we can just find that here on our graph is -1. So h, luckily for us, h is -1. Okay, that was a doozy. Number 27. A 10-foot ladder is leaning up against the wall. If the base of the ladder is situated 4 feet away from the base of the wall, what is the angle of elevation of the ladder? Draw pictures that depict the situation and label the relevant information. Right, it's the nearest tenth of a degree. All right, so let's draw this. Walls and the ground typically drawn perpendicularly. So we know that's a right angle. We know this is a 10-foot ladder, and the base of the ladder, which is down here, is situated 4 feet away from the base of the wall. So they're telling us that that's 4, and they're asking us for the angle of elevation, which is this angle here. Okay, so to find our angle of elevation, because we've been given the adjacent side and the hypotenuse, we're going to use cosine. Because remember, cosine of theta is equal to adjacent over hypotenuse, which in this is 4 over 10, which we can simplify down to 2 over 5. Okay, so let's write this. Cosine of theta is equal to 2/5. Now, to get rid of the cosine, we're going to use our calculator. We're going to find the arc cosine of both sides. So we're just going to apply arc cosine to both sides. Cosine and arc cosine cancel out, and we're left with the angle of elevation theta is equal to arc cosine of 2 over 5. Now, I don't have my calculator handy, so I'm just going to let you type that into your calculator. Make sure it is in degree mode and round to the nearest tenth. So that means round to the nearest 1 decimal place. So this, just do this in your calculator. 28. Solve for x and round your answer to the nearest tenth. Okay, 3 to the x equals 12. There's a couple ways we can solve this. The fastest way would just be to take the natural log of both sides, because natural log is the key, or logarithmic functions in general are the key to remove exponents up and out. So we can write natural log of 3 to the x as 3 times natural log of, sorry, not 3, x, we take the exponent up and out, x times the natural log of 3 equals natural log of 12, which we can then divide both sides by natural log of 3. Those will cancel, and we're left with x equals natural log of 12 over natural log of 3. Now, you might remember that this is also the change of base formula. So let's solve this a slightly different way, and then I'm going to sleep. 3 to the x equals 12. Instead of using natural log, which remember natural log of x means log base e of x, instead of using base e, we might want to use base 3 here, because the base here, well, it's 3. So let's try that. We do log base 3 on the left side, log base 3 on the right side. This still follows the exponent or the power rule that says we can take our exponent up and out and put it in the front. So this is going to give us x times log base 3 of 3 is equal to log base 3 of 12. Log base 3 of 3 is like asking 3 to what power gives us 3, which is 1, so that cancels out, and we're left with x equals log base 3 of 12. If you have a fancy calculator, you can type this in. If not, we need to use the change of base, which allows us to do natural log of 12 over natural log of 3, which is the same answer we got over here. And with that, I bid you adieu.